our weekly series on learning about the practical aspects of machine learning and how we can utilize them. Now, today, we are going to talk about Kubernetes. Okay. Kubernetes is an aspect of machine learning which is very useful from a practical standpoint. Kubernetes is a software which allows us to monitor the utilization of our resources done by machine learning applications. And the benefit of Kubernetes is that it is available on various different platforms. It is available on local systems. It is, of course, up to a limited capacity, it is available on local systems. It is available on our cloud platforms. Whichever cloud platform you want to talk about, Amazon or Azure or GCP, right? Whichever platform you want to go ahead with, it is available on that platform. Okay. So in this context, let us see what exactly is the utilization of Kubernetes in context of machine learning. So let's go ahead and talk about Kubernetes. What is Kubernetes? What are the different components of Kubernetes? What is the architecture followed by Kubernetes? Okay, and we will go and understand the architecture. What is the runtime? What is the meaning of CI/CD pipeline? And of course, let's get started. So, first of all, what exactly is Kubernetes? Now, Kubernetes is a platform which we will be using for deployment, scaling, and management of container-based applications. Now, we have already covered what are these container-based applications. What is the meaning of container-based applications, right? We are talking about, of course, our Docker applications. So Kubernetes is a platform which will allow us to manipulate these container-based applications. Okay. So it was originally developed by Google, but now it is part of the Cloud Native Foundation. So what is the benefit of being in the Cloud Native Foundation? It means that it is open source. Okay, it is open source. That is the big benefit. Okay, everything on Kubernetes that you will be looking at will be all available as part of our open source platforms. Okay, every single thing that you're looking at is going to be open source. Okay, so the core functionalities is things like scheduling workloads in containers across underlying our infrastructure. Okay, so then what is Kubernetes not? Okay, what is the limitation of Kubernetes? It's not a limitation. Maybe we can say that it is a difference between Kubernetes and other structures. So we have something known as platform as a service. Okay, so what does platform as a service do? It allows people to develop, run, and manage applications without dealing with the complexity of building an underlying network. Okay. So you don't need to worry about the underlying infrastructure here. So that means whatever you're doing on Kubernetes, it is available on, so sorry, whatever you want to build, you can build on these cloud platforms without having to, develop the entire architecture. So this brings us to the question, why is Kubernetes not considered as a platform? Why are we saying that it is not platform? Now, the reason why Kubernetes is not considered as part of the cloud computing stack is it's very complex. There are a myriad of reasons. Okay. So Kubernetes is a container orchestration tool. This will automate deployment, scaling, management. Okay. These are the things that it will automate: deployment, scaling, and management. Right. So it will give you the necessary infrastructure which you require to run any containers, but it will not give you the application development and deployment environment typical of the platform as service, or PaaS, as you want to call them. Okay. The second major reason here is that Kubernetes will offer more control and flexibility over the underlying infrastructure. So we are saying that if you're using a service which says that, okay, this is a platform as a service, right? So in that context, Kubernetes gives you a greater degree of control over whatever underlying infrastructure you are using in comparison to PaaS. You have the ability to do various things, such as choose your own operating systems, create your own configurations, network configurations, storage solutions, and other things. Whereas if you're using a platform as a service, it will simply abstract these details away. Now, there is also a split of the responsibility when compared with PaaS. Okay. So in a PaaS environment, the provider manages almost all the aspects of the infrastructure and the middleware, as well as the runtime. In comparison, Kubernetes users are required. So instead of something that is being done automatically, you are required to manage the application configurations, dependencies, and runtime environments. Okay. Then we have different kinds of services that can be integrated. The different services that can be integrated often will include development tools, databases, and other services which are already configured. So we are talking about the entire architecture, right? For example, a database is a critical part of machine learning. Now, if you're developing machine learning solution using platform as a service, in that context, your system is already configured for various services. Okay, so database and development tools or any other service which you might be requiring. Since it is already configured, it makes things easier to use. And Kubernetes, while it has the capacity to integrate these various services, it does not provide out of box integration in the same way. Okay. So we require additional setup and configuration. Okay. Then we also have the development environment. So when you're using any kind of platform as a service, you will have a comprehensive environment which is tailored for application development. This includes things such as tools, frameworks, and services, which will streamline your entire development process. So end-to-end deployment is what we are talking about. Okay. And not just end-to-end deployment, we are also talking about application development. As you will see as part of this Kubernetes course, we will not be looking to do a application development process. That is not part of Kubernetes at all. Okay. Instead, what we will do is we will focus more on the deployment and management of containerized applications. So this term comes back again, containerized. So if we were to revisit this terminology and somebody says, okay, containerized, what is the meaning of containerized? What do we mean when I say that, okay, I am going to do containerization? Containerization is a process of creating Docker containers. Okay, that is what we mean. All right. So that is what containerization is. Okay. Then we also have, so coming back to Kubernetes from containerization, sorry for that. We are simply talking about management of these containerized applications alongside the deployment. So I am not recreating, okay, I am not recreating a application. I am simply just utilizing the application. Okay. So this is something that we need to keep in mind. Okay. Now, we also have abstraction level. So abstraction level in platforms will give you a higher level of abstraction. So it focuses more on the application layer, and it will reduce the requirement of you to worry about, the lower end stuff, whereas Kubernetes will operate at a lower service. Okay. So Kubernetes, in comparison to platform as a service, requires a higher degree of knowledge your in comparison to our platform as a service. So Kubernetes can sometimes be called as a container as a service, or maybe even infrastructure as a service. Okay. So now Kubernetes falls as part of the CI/CD pipeline. So let's understand what is this CI/CD pipeline. What exactly is covered as part of the CI/CD pipeline, and what are the different tools which you can use. So we have three aspects that we are going to look at. Okay. And we will see where Kubernetes falls in this architecture. Okay. So CI/CD/CD pipeline. Okay. So what is CI/CD/CD pipeline? So CI is continuous integration. All right. So here we are gonna talk about things such as merge and test. Okay. So we're gonna look at merging and testing of different code changes related to the different steps of a crisp MLQ, such as data preprocessing. We will talk about model training, and we will talk about evaluation. Right? These are the different features that we will look at. Okay. So every time you write the code, okay, now keep this thing in mind that code will continuously change. Okay. So every time we write the code, it will trigger automated tests. Right? This will include things such as unit test, integration test, as well as model performance test. We will also be looking at data validation. Okay, so what is the meaning of data validation? In terms of data validation, we are going to be looking at the quality standards and the suitability for training. Okay, whether something is up to the mark or not, and that something is our data. So we will be checking if our data is up to the mark or not. Okay, then environmental consistency. Okay, so we can and we have to ensure that there is a consistency in the environment. So what is this environment that we are talking about? We are talking about nothing but our Python environment. It could be using virtual environment from Python itself directly, or it could be from Anaconda Navigator. Either way, you can talk about environments. Okay, so we can utilize this step to ensure that we have a consistent environment for development and testing. So here is where Docker containerization shines. Because as we have learned, Docker will isolate your application. Okay, Docker will isolate your application, right? Then we have continuous delivery. Okay. Now that you have taken into account continuous integration, the next step that we have is continuous delivery. Okay. This can also be called as continuous deployment. Okay. So this is the process of deploying models in production. Of course, developing models is one thing, but getting some practical aspects out of those models is another. Okay, so we can deploy models to productions, we can enable rapid iterations, and we can also look at continuous updates. So what are some of the key features? Key features include full automation. Okay, so instead of having manual deployment tools, all right, instead of deploying something manually, you want automation end-to-end automation for deployment. Okay. Then we also have monitoring and logging. Okay. So we are going to include robust monitoring and logging where we will keep an eye on the model performance and we will try to detect anomalies. Okay. If any new model deployment is causing any issues with the existing models, then we are going to try and detect that as soon as possible. We will also implement mechanisms to quickly roll back previous models in case any issues arise. So let's say that you have deployed a new model. Okay. Now, somehow that new model, despite performing well in a testing environment, is struggling in the production environment. And this could be for a myriad of reasons. There is no specific reason that it will be following. It can be n number of reasons, right? It can be n number of reasons. In such a scenario, okay, in such a scenario, we can use our continuous deployment to roll back to whatever steps we need to roll back to. And here we will also have the option of scaling the deployed models as per the demand. So if you have a large user base which is active during certain durations, let's say that we split a day into 12 to 8, 8 to 4 p.m. and 4 to 12. And we can just track how many users per slot. Based on this information, we can decide when do we need to scale up our deployment. Okay. And this is where something like Kubernetes, along with various other tools, will come into the picture. Okay. Then we also have continuous testing. Okay. So what is continuous testing? So this is a process where we will automate the various tests which are involved in the machine learning lifecycle. So not just towards the end, but anywhere. So we will be looking at data validation. So we can keep an eye on data quality. We can check if the data pipeline is clean and if the data is reliable, right? Then we also have model validation. So this is done to ensure that the model performance is as expected. There is no deviation from the expected performance. You do not want to move away from whatever performance requirements you have. Okay. So we will be looking at various different performance metrics, and we will also be, of course, looking at bias checks. So for example, is the model displaying any kind of bias or not? It should not, right? That is the ideal requirement. It should not display any kind of bias whatsoever, because bias is going to give us misleading results. And we don't want misleading results. We want the results to accurately represent the situations. Okay. So now we will also be looking at performance, because performance is critical, right? It doesn't matter how good of a model you have developed. It doesn't matter how great your model looks. If the performance is not good, okay. If the performance is poor, then the performance is poor. As simple as that. Okay. So in that context, we have to check the performance and scalability under various different circumstances. And then we will look at the feedback loop that gets created. Okay, so we'll focus on data quality, model performance, and system behavior. Okay, fine. How does it work? So, what is the workflow that is followed? The workflow is very straightforward. We start off by looking at code and data commit, which is part of continuous integration. So developers will commit code changes and data updates to the repository. Whatever repository that you have, you can update in that. Then we will have automated build and test. Okay. So in terms of the continuous integration system, so let's say that you want to do an automated build and you want to run tests on code and data. It will validate the model performance. Okay. Then we have model training and validation. Okay. So models are going to be trained and validated based on the latest data and code changes. Okay. Then we have staging of deployment. Okay. So validated models will work in staging environment for further testing and validation. Then we will have continuous testing come into the picture. So what we want to do is in the staging environment, before we go to the production stage, we want to check whether our data and the model are up to the necessary quality or not. So before we even get into the phase of going live with any changes, okay, we can simply validate whether the data and the model quality is up to the mark or not. Okay. And then we have continuous production deployment. Once everything is done, okay, you can say that successful models will be automatically deployed in production. Okay. But in continuous delivery, there still might be an aspect of manual approval, which might be required. Okay. So by integrating our CI/CD practices into the machine learning workflows, we can achieve more reliable, scalable, and efficient deployment for machine learning models, ensuring that they deliver consistent and high quality results. Okay. Yeah. So that's all we have for today, folks. I think it's already 6 o'clock. I just looked at, I just realized the time. Okay. So thank you so much for joining, and I'll see you guys next week. Bye bye.